Alright guys, let's see how we can solve question 68 from the second chapter of the Mechanics of Materials by Beer and Johnston. And we have a fabric used in air-inflated structure that is subjected to a biaxial loading that results in normal stresses in X and Y direction. So we have the value for, X and Z direction. So we have the value for each of them. Knowing that the properties of the fabric can be approximated as, so we have the elastic modulus 12.6 times 10 to the 6, and we also have the Poisson's ratio of 0.34. We need to determine the change in length in three different conditions in side AB, side BC, and the diagonal AC. So if we look at this, we have a right triangle in here where that side is 4, this side is 3, and based on the Pythagorean theorem, the hypotenuse would be the square root of 4 squared plus 3 squared, which is 5. So the givens of the question, theta x is equal to 18 ksi. Since our stress is only in x-z direction, there is no sigma y, so this one's 0, and the sigma in z direction is 24 ksi. So we have a formula for finding the strain in each of these directions. So we'll start with the epsilon x. So we have 1 over elastic modulus times sigma x minus Poisson's ratio times sigma y minus Poisson's ratio times sigma z. So whenever you have x, whatever axis you have in here, the first one is that axis and the rest would be the other two. We just have to multiply the Poisson's ratio, and we have the same story for epsilon in z direction. 1 over e, again this one's z, this will be z, and the rest just have to multiply by Poisson's ratio. So these parts are 0 because there is no sigma y. So we should be able to find the epsilon or the strain in x direction and z direction. So 1 over e, our e is 12.6 times 10 to the 6 psi. Keep in mind that this is in psi unit and our sigmas are in ksi, so we need to be consistent with the unit, and we know 1 ksi is equal to 1000 psi. So we're just going to multiply the values of stress by 1000, so 18 times 10 to the 3 minus Poisson's ratio 0.34 times the z would be 24 times 10 to the 3. So that should give us the epsilon or the strain in x direction, and same for the z. 12.6, same material, same elastic modulus, psi. Again, we have to watch for the units in here, minus 0.34 times sigma x, which was 18,000. So let's just find these values very quick. All right, so the strain in x direction would be 780.95 times 10 to the minus 6. And for the z, this will be 24, this will be 18, the rest is the same. So 1.419 times 10 to the minus 6. All right, so this is our strain in x and z direction, but what the question is asking us is basically the change in length, where we show it with alpha, and we know with delta, so the epsilon x is equal to the change of the length that we have, which in here we are looking for AB in the A part over the length of AB. So the change of length would be basically the length, which is 4 inches for AB, times the epsilon x, this value 780.95 times 10 to the minus 6. So that's going to be the answer for the A part. So basically 4 times 780.95 times 10 to the minus 6. So 0.00312 inch. We're going to have very similar, so that's the A part. For the B part, we are looking for the BC, which is again delta BC over the length of BC. So delta BC would be, that side is 3, and the strain would be 1.419 10 to the minus 6. Let's see what this gives us. Yeah, I think I made the mistake in this calculation over here. So it's actually 10 to the minus 3. I don't know why I put -6 because that value is definitely bigger than the previous one. So it's 10 to the -3 actually here. So we need to just multiply this by 1000, which is going to be 0.00426. That's going to be the B part of the question. And the last part is the trickiest part of this because we are looking for the delta CD, and for finding that, based on the Pythagorean theorem, we know that AC squared is equal to AB squared plus BC squared. So just to simplify things a little bit, just going to call this C squared, this one A squared, and this one B squared. And now if we do the derivative of each side, on the left side we get 2C derivative of C is equal to 2A derivative of A plus 2B derivative of, and basically these are representing the change of the length in each of those sides. So for this one, DC is actually delta AC, this is delta AB, and this will be delta AC. And also we can cancel out all the 2's in here. And for finding the delta AC, which is what the question is asking, we have C times delta AC. We have A, let's just get back, AB is 4, so 4 times delta AB, we already figured out in the A part of the question. It's this value, 0.00312. And B is 3, and we found delta BC in the B part, 0.00426. And this should give us the delta AC, which is basically what we have on the right side divided by 5. So let's just calculate this very quick. 4 times 0.00312 plus 3.00426 divided by 5. And this is going to give us 0.00505 inches. And yeah, that's going to be the answer for the C part of the question. Hope everything was clear. Let me know if you guys have any questions. Again, I made a mistake in this part when I was calculating. I put -6 instead of -3, but this should be good for the final answer of this question. And yeah, let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.